Hi friends, welcome back. Today we're talking about solving equations with multiple logs. There's two different ways to do this. There's two different types that you, not two different ways, two different types of equations that have multiple logs on how to solve these. The first we're going to talk about are log equals log. So log equals log is what we're trying to get. What do I mean by that? Well, here's our first example. You'll see that we have log plus log equals log. We can't have that. What we have to have is a logarithm on exactly one logarithm on either side, on both sides. So when we do that, we want to use our rules of logarithms in order to simplify this down. Remember, our rules of logarithms tell us addition is really multiplication. So to compress this down, we would have log base 4 of 8 times x minus 9 equals log base 4 of 8. So when we have this now, we have exactly one logarithm on both sides. Then we can cancel it straight out, just like that. So when we do that, we end up with 8 quantity x minus 9 equals 8. So I could distribute that 8 through there, but I'm kind of lazy, so I'm just going to divide both sides by 8. And if I do that, I get x minus 9 equals 1. Add 9 to both sides, and I would get x equals 10. X equals 10. So if we go and we take that 10 and we plug it in here, we have, we wouldn't plug it here, but here we would have 10 minus 9, which is 1. So that would work. So we're allowed to do that. If that gave us a negative, would not work, and we would not be allowed to do that. Okay, I've left some space here because when we get to type 2, I want to show you how we can go back and do this one. And so I'm going to rewrite it down here so that you can see on our second method what we do for that guy. Okay, so for our second example, still log equals log here, we have this guy right here. So again, you'll see that we need exactly one logarithm on each side, and I have 2 here, so I need to use my rules in order to compress this down, right? So we would have, remember, addition means multiplication. So x plus 2 times 3x minus 2 equals. Also remember that if we have something in the front here, it gets booted to the back here. So this becomes natural log quantity 2x to the second power, because I took that 2 and I booted it to the back. Now notice I used parentheses here because it applies to both the 2 and the x. Okay, so now I have exactly one logarithm on each side. Again, what I can do is boom, boom, cancel those out. Let's go ahead and FOIL this guy. So if we've got, okay, so what we have is 3x squared minus 2x plus 6x minus 4 equals 4x squared, because I went ahead and took that 2 and distributed it to both of those. I see that I have an x squared here, so I want to set this equal to 0. That's always a good rule of thumb. So minus 4x from both sides. And at the same time, I'm going to combine my like terms here. So that gives me 4x. So I have negative x squared plus 4x minus 4 equals 0. I think the best way to solve this is going to be to factor. However, when we factor, we don't want a negative in the front here. So I'm going to multiply everything by negative 1. And all that does is just change my sign. So I have x squared minus 4x plus 4 equals 0. Let's go ahead and factor. So x, this tells me same signs. This tells me negative, negative. And my factors of 4 are 1 and 4 and 2 and 2. I need a negative 4. So negative 2 will give me negative 4. Using our zero product property, we get x minus 2 equals 0, x minus 2 equals 0. If we solve both those, we get the same answer. So we have 2 answers, it just happens to be the same. X equals 2, x equals 2. Now these are potential answers, or it's a potential answer. We have to go back and plug it in. If we take this 2 and we multiply it up here, 2 plus 2 is 4. That's a positive number, so it's okay. 3 times 2 is 6, minus 2, that's 4. That is also positive, so these work. So our answer is x equals 2. All right, let's take a look at our next one. Now remember, when we have exactly one logarithm on each side, you can just cancel them straight out like that. Bam. That leaves us with 5n minus 10 equals 3n minus 10. If I minus 3n from both sides and add 10 to both sides, this gives me 2n equals 0. Okay, if I divide both sides by 2, you'll see that I have n equals 0. All right, let's go back and plug it in. If I plug that in here, 5 times 0 is 0. 0 minus 10 would give me a negative 10, and so I would have a negative here. That, not allowed. So this would be no solution. No solution. Okay, so let's take a look at the next one that we have, which is our second type is log equals number. Log equals number. So for this guy, instead of log equals log, we want to get it log equals number. Now you have to have, so in the entire equation, we want just exactly one logarithm. I see here that I have 2, so I need to compress those down by using my rules of logarithms, which addition means multiplication. So log base 6 3x times x minus 1 equals 3. Now that I have exactly one logarithm, what I can do is use my scorpion or snail, however you want to call it, to say 6 to the third power equals 3x quantity x minus 1. Okay, let's clean this up a little bit. So 6 to the third power is 216 equals 3x squared minus 3x. Now, I know that I can divide all of these by 3, so let's go ahead and do that to make it a little bit easier. When I do that, I get 72 equals x squared minus x. Okay, so I have an x squared in there, so it's a good rule of thumb. Let's set it equal to 0 by minusing 72 from both sides. So if I do that, I get x squared minus x minus 72 equals 0. And I'm going to rewrite that right up here. X squared minus x minus 72 equals 0. Let's go ahead and factor this guy. X. This tells me different signs, so plus and minus. Now list all your factors of 72. I've gone ahead and done it over here just so I didn't forget any. And I did it in order 1, 2, 3, 4, not 5, but 6, not 7, but 8. And then after 8 comes 9 and it's already on the board. So we're good here. So I need a positive and a negative that gives me negative 1. So if I do positive 8, negative 9, positive 8, negative 9, that will give me negative 1. I may factor differently than you do. That's totally fine. If you've got a way that works, excellent, keep with that. So let's use our zero product property to say x plus 8 equals 0, which means x equals negative 8. X minus 9 equals 0, which means x, if I add 9 to both sides, I would get x equals 9. So these are my two potential answers, but they aren't actually answers yet because I have to go back and double check. For example, this negative 8 here, if I take that negative 8 and I plug it in right here, 3 times negative 8 is negative 24. Not allowed to have a negative here, so straight away, this one, got to get rid of it. Now what about 9? 3 times 9, that'll give me a positive number. 9 minus 1, that'll give me a positive number. So this one is okay to use. All right, example 5. So this one looks a little tricky and you see exactly one logarithm on either side. I don't want you to think this is a log equals log because it's not. There is exactly one log on each side, but we still have this plus 1 here. That's not attached to this log here. So you have to be very careful here. What we're going to do instead is use our rules of logarithms again. So we're going to minus log x minus 2 minus log x minus 2. So what we have now is log 7x plus 1 minus log x minus 2 equals, these canceled out, equals 1. Now remember, subtraction means division when we're collapsing our logarithms. So log 7x plus 1 divided by x minus 2 equals 1. Now we have exactly one logarithm, and so we can use our snail. Remember, if the base is not shown here, it's a base 10. So again, if I use my snail, I would say, all right, 10 to the 1 power equals 7x plus 1 over x minus 2. Now, personally, when I have a fraction involved, fraction equals fraction, I can cross multiply, and I can easily turn this 10 into a fraction by putting it over 1. Remember to protect your addition subtraction when you have fractions. Okay, so if we do this times this, that's going to give us 7x plus 1 equals this times this, 10 times quantity x minus 2. Let's go ahead and move this up here. So 7x plus 1 equals, and go ahead and distribute here 10, and so 10x minus 20. Okay, so let's go ahead and solve for our x. I'm going to minus 7x here, plus 20 here, plus 20 here. I end up with 21 equals 3x, divide by 3, divide by 3, x equals 7. Okay, this is a potential solution, but it's not actually our solution until we go back and double check. If we go to the original problem, when we put in our 7 here, that would be 49 plus 1, so that'd be 50. That works. 7 minus 2 here, that would give us a positive number, so that works as well. So this is our solution. So excellent job. Okay, that is it for these guys. If you have any questions, let your teacher know. Otherwise, great work, and we will see you next time.